सक्सेसफुल होनी चाहिए। So a very good morning to all of you. There is some network issue. Okay, so I have joined from my mobile phone. Just let me know if the screen is blurred or there is some certain issue. So thank you very much for joining the lecture, and today also we are going to continue with smart substation. Hope my voice is visible and my screen is also visible. Okay, so we know a little bit about smart substation. Let us see it again, once again, when we talk about the substation. So basically this particular substation, that will be a focal point of an electricity generation, transmission and distribution system where voltage is transformed. Substation means what? It can be at a generating station, it can be at a distribution end, and as well as a transmission end. So we are just transforming voltage from one level to another level. Okay, so electric power flow that will happen through several substations, that will be between generating plants and actual consumer. There could be a number of stations. It is possible that you are taking power from southern region of India where a nuclear power station is located, and you are utilizing the power in Kashmir. So there could be a possibly intermediate station would be there. You know what would be the reason regarding the power factor correction and voltage, power quality issue. So you require a number of stations. So substation, that could be your transmission substation, distribution substation, it could be collector substation, or only switching substation. So there are a number of substations, different kinds of substations. So we are basically talking about the automation of substation. We very well know what are the functions, general functions of substation, that is voltage transformation. Already we discussed that. Then connection point for transmission and distribution power lines, switch yard for electrical transmission and distribution system configuration, monitoring points for control center, protection of power lines and apparatus, communication with other substation and regional control center. So these are basically functions of a substation. So continuing with substation and feeders, they are basically source of critical real-time data. Already we discussed a little bit about what we mean by the real-time data, or we are interested in data of voltage, current, frequency and other events. So these are the points from where usually we capture what is the value of voltage, what is the value of current, or what is the performance of a distribution transformer. So feeders and substation, they are sources for critical real-time data for efficient and safe operation of the utility network. The goal is to operate the network in order to maintain reliable power supply. And when we are maintaining the reliable power supply, the operation, whatever performance is there, it should be efficient. And another thing is the safety. It should be there. When we are talking about the critical real-time data or the real-time data, which is usually called as operational data, so these are nothing but these are instantaneous value of power system, analog and status point. You could say volts, already we talked about that, volts, amperes, megawatt, MVAR, circuit breaker status. Along with that, we are also interested which circuit breaker is open, which one is the closed. So circuit breaker status and switch position, what is the position of the switch. So these real-time data are time critical. We already discussed at particular time voltage may be different than at a particular time. So these data are time critical and are used to protect monitor and control the power system. So that's why the data is required and we are interested in automation. There is also wealth of operational data available from the field devices, that is non-real time. Okay, so we can call it as non-operational data. This data may include files and waveforms such as an event summaries. Okay, certain event happened, so exactly what was the reason, what was the voltage, current at that time, and what actions has been taken. So you will get these data as a non-operational data. So it could be your event summaries, oscillographic event reports, sequential event records, in addition to supervisory control and data acquisition, that is your SCADA, like points, status and analog points, it can be included in that. And they have a logical state, a numerical value, certain logical state 1, 0, whatever, or some numerical value indicating, okay, 500, some concluding point would be there. So that is non-operational data. Basically, the non-operational data, this is not required by the SCADA dispatcher to monitor and control the power system. But if you are having this non-operational data, it is going to help you to make operation and management system asset more efficient. You are having experience, basically, you could say. This is nothing but experience. It is giving you the knowledge. So this will help you to maintain reliable and more efficient system. Your operation that will be more reliable, more efficient if you are having this non-operational data. Then when we are talking about smart substation, so it consists of various things. It includes intelligent electronic devices, IEDs. So what are these IEDs? This is part of substation. So this topic is also given separately in your module. We are covering this topic under smart substation, because without this, a smart substation is not possible. Without IEDs, without sensors, it is not possible. Without SCADA, it is not possible. Or you can say without communication, the smart substation is not possible. So let us talk about IEDs. What are basically IEDs? So you can say the intelligent electronic devices, it will consist of microprocessors. So we will say these are the microprocessor based devices. Now it will be having certain capability to exchange data and control signal. If there is certain event where the voltage is increased or the frequency is not in limit, okay, it is deviating. So certain signal has to be transmitted to some equipment. Okay, the frequency is deviating. So what you have to do, suppose the signal is for generator, governor action. Okay, so what you do, you start producing more, just increase the speed so that some output from generator can be enhanced, so that frequency can be maintained in a limit. So it should be whatever if there is IEDs, so they will be having capability to exchange the data. Okay, you are having this data, I am having this data, according to some decision, control signal can be sent to another IEDs. Okay, that will be basically your electronic meter, controller, SCADA, etc. And how this exchange data is going to take place? Definitely we need one communication link. So over a communication link, they are going to exchange data as well as control signal can be sent. If we talk about the functions of IEDs, so IEDs is going to perform functions of protection, monitoring, control and data acquisition. Where it is going to perform? IEDs will be at your generating station, substations, in intermediate station you can think about, and along feeders, and are critical to the operation of the electrical network. So it will function in generating station, substation and along the feeders. What they are going to perform? Protection, monitoring, control and data acquisition. Data acquisition is quite important. Then intelligent electronic device, they are widely used in substation for different purposes. It is not only one purpose for that the IDs is used. In certain case, they are separately used, means a separate basis. IDs is used to achieve individual functions. It could be any functions, like you can say the differential protection is required, a particular kind of, so you can use the IDs. Distance protection, individual IDs can be used. Overcurrent protection, metering, monitoring. There could be multifunctional IDs, intelligent electronic device, which means it is going to perform more than one function. Okay, if it has capability, then you will say it this IDs, intelligent electronic devices, have multifunctional IDs, you can call it. So it can perform protection, monitoring, control and user interfacing functions on one hardware platform. So that will be your multifunction IDs. IDs, they are basically a key component of substation integration and automation technology, because we are talking about substation automation. That's why it is a key component of substation integration as well as automation. Substation integration, what we exactly mean by, so it is going to involve, when we are talking about substation integration, so it involves integrating protection. First thing is protection, second is the control, the third one is the data acquisition function into a minimal number of platform. See, the minimal number of platform, as if the one is sufficient, okay, one number of platform is sufficient, then it should go with the one. If there is requirement of only 5 number of platform, so 5 is okay, you not need to go for 10, 6, 7, 8 or 10. Okay, so minimal number of platforms when it will be there. So ultimately when you are utilizing few things, so what would happen, it is going to reduce the cost. Reduce, one is the investment, or you can say the capital cost, and the second is the operational cost. You could think about like the manpower requirement, that would be the less. That could be also, and the other things also going to reduce. This is going to reduce panel and control room space. You not need a larger space. In a smaller space, things can be done. If in a smaller number of units, number of platforms, you are able to integrate protection, control and data acquisition in one system. Like in your mobile phone, you are having camera, you are having recorder, you are having radio, you are having n number of features. Otherwise, what you need to do, you need to carry your camera separately, you need to carry your recorder, you need to carry n number of devices. So when you are having everything in one place in a compact device, so it is going to require a less space, and you not need to carry convenience and compatibility. That is about 4. In the same way, when we are talking about the protection, control and data acquisition functions, that is integrated into a minimal number of platforms. So it is going to, first thing is cost is going to reduce, capital investment. The second one is operation cost, it is going to reduce. The third one, whatever the space required, that is going to reduce. So that there also you are going to save in investment cost, that is going to save, as well as it is going to eliminate redundant equipment and database. Whatever is not needed exactly, that can be you do not need certain database, the data which you are collecting, but it is not required, so no need to collect that. That can be avoided basically when you are going with substation integration automation with IDs. Automation involves the deployment of substation and feeder operating functions and application ranging from SCADA and alarm processing to integrate reactive volt ampere control in order to optimize the management of capital assets and enhance operation maintenance efficiencies with minimal human intervention. The objective is to reduce error, human error basically. When humans are involved, at that time the chances of errors are higher. So when you are going for automation, so what you could do, you can enhance operation and maintenance efficiencies. It will become efficiency when there will be less error. So there will be minimally intervention of human involvement will be there. So when you are going with automation of substation, so it is automation is involving deployment of substation and feeder with certain functions along with SCADA. We talked about the multifunctional IDs that can be used. So when the multifunctional IDs are used, so they must be compatible with IEC 61850. We already discussed little bit about what is IEC 61850. So it is communication protocol, interoperability with communication network. So that is required. So multifunctional IDs, they are fully IEC 61850 compatible and compact in size, so that they combine various functions in one design. They are going to allow for a reduction in size of the overall system, and of course there will be improvement in efficiency. This is also going to improve robustness and will provide extensible solutions based on mainstream communication technology. Whatever is your mainstream communication technology for exchanging data control, that could be done. ID technology also helps utilities to improve reliability. That is the goal basically. Gain operational efficiencies can be improved, and enable asset management program including predictive maintenance, life extension and improved planning. So when ID is there, means automation we are talking about particularly, so certain goals can be achieved. One important goal apart from reliability, gain operational efficiencies, that is asset management program. You are having certain asset, you are having number of transformers, you can think of that, consider that. So there should be its maximum utilization. Nothing should be, you not need to procure another one. If you are having that asset, it should be optimally utilized. So that management program can be included. So under that, okay, you know that there is need of replacement of oil transformer, distribution transformer. If you are having this ID technology, so they will communicate you, okay, the level of oil is below, or it becomes too thick, it becomes too dark, so just replace it. Okay, it cannot operate its function. So what can active maintenance can be done. Okay, engineer will go, or whatever, whoever is concerned, they will replace it. And so what it will do, it is going to increase reliability of supply, because there will be no outage. Okay, there will be scheduled outage, so people would be aware about that. So it is going to increase the efficiency, and of course the life is going to increase, because no need to pay more. If suppose oil is not replaced timely, so what would happen? Windings may get burned, because it is installation, cooling is going to be affected. So what you need to do, you need to replace the winding. So that will involve too much cost instead of the preventing maintenance. So that is basically going to help. The second thing which automation, substation automation is going to use, that is the sensors. Already though we talked about the sensors. So the main function of sensor is here to collect data from equipment, that is your, of course, the equipment, power equipment which is available at substation yard. Think about transformer, think about circuit breakers, you can think about the power lines. So it is going to collect the data from these devices. Now there is advancement in technology. We all know that there is advancement in digital and optical technology. So in combination with communication, the sensors are becoming more advanced. They are available with advanced technology. That is, you can say digital and optical, both are combined. So whatever the sensor, they can acquire different type of asset related information, number of significant information they can capture basically. Original copper wired analog apparatus are now replacing by optical apparatus with fiber based sensors, so that monitoring and metering can be done effectively. So now that is the change in the sensor technology. Earlier there were some wired were there, okay, so they were transmitting that. Now there is fiber based sensor, optical fiber is there, so that is advancement. So we are not going into deep what is advancement. Definitely this is going to increase the speed of transferring or exchanging the data, that is possible. So the most prominent advantage of these sensors, that is higher accuracy, there will be no saturation, size is also small, weight is small, it is from environment point of view, it is safe as well as friendly, that is required. It should not harm environment as well. Basically these are avoiding the oil and SF6 sensor that is replaced with this advanced technology. Of course the performance will be higher, wide dynamic range, high bandwidth, and the most important thing is the low maintenance. And low maintenance is there, the cost, running cost is ultimately going to reduce. The main advantage of optical sensor that includes wide frequency bandwidth, wide dynamic range and high accuracy. These sensors allow monitoring and control that to be implemented with two important application features, which includes single sensor may serve different types of IDs. If you are having one sensor, different type of IDs can be served. Single sensor may serve a large number of IDs via process bus, so that can be done basically. Those sensors need accurate time synchronization because this is an important aspect. So that's why the time synchronization is required with inputs and the sample which is going to be processed on the process bus. Anyway, you could understand this. Everything cannot be explained actually. Then the third part, which smart substation automation requires, that is the SCADA. You know too much about SCADA, but let us see what information we have. So basically when we talk about SCADA, so it refers to a system, or you can say a combination of system which collects data. It is going to collect data from various sensors. You have placed sensors at certain location, at your plant, at remote locations, and these are going to send the data to a computer which is placed at a central location. Okay, so you can call it as central computer system, from where according to data the control signal can be sent, and remotely you not need to visit personally to that particular location. Remotely you can operate that because IDs are also there. SCADA is a term which is broadly used to portray control and management solutions in a wide range of industries. The electric power industry has a specific set of requirements that apply to SCADA system. Every industry has a different set of requirements. So definitely the electric power industry has a different requirement. So when we talk about the electric utility, so what is the primary requirement or the primary purpose? That is to acquire the data, real-time data. Specifically, we are interested in real-time data from various devices which are located at the power plant, transmission and distribution substation, distribution feeders, and number of things can be included from where we require. So it is going to, this SCADA system is going to provide control of the field equipment and present the information to the operating personnel, POSOCO, power system operator, independent system operator, whoever is there. So the real-time monitoring and control of substation and feeders, if you think about the time, it is only 1 to 5 seconds. Just think about that. I said 1 to 5 seconds, it's over. So that monitoring and control could be achieved with the help of SCADA. SCADA, it is accepted globally for monitoring and control of electric power system on real-time basis, particularly at generation and transmission system. There are some remote terminal units. We discussed little bit about this. The remote terminal units that are used to collect analog and status telemetry data. There are remote terminal units, RTUs. Its function is to collect analog and status telemetry data. Of course, it will be from field devices, and the same has to be communicated to control commands to the field device. So these are the functions of basically the remote terminal unit. These RTU are installed at a centralized location such as the utility control center, and our front-end data acquisition equipment, SCADA software, operator graphical user interface, GUI, which is commonly known as engineering application, which acts on data, historian software and other control. So we are talking about the RTUs, RTU that is installed at a centralized location, which are front-end data acquisition equipment. SCADA software operator that will be included in that. What is the recent trend in SCADA? It includes providing increased situational awareness. At a particular situation, the data would be different. So that awareness can be obtained, situational, that can be obtained through SCADA. That is the recent trend. Through improved GUI, graphical user interface, whatever the monitor you will be having, user interface, graphical, that is enhanced basically. And presentation of data and information, intelligent alarm processing. Alarm processing is also intelligent. The utilization of thin clients and web-based clients. You are having web-based client that can be also utilized. Improved integration with other engineering and business system. You are going to integrate with other engineering, not only electrical, other engineering can be integrated, other business system can be integrated, and enhanced security features. Security is important thing. Typically, control and data acquisition equipment compose a system with at least one master station. There should be one master substation, or more remote terminal units, and a communication system. Communication system is required. Without that, nothing can be happened. The electric utility master station is usually located at an energy control center. You can call it as ECC, and RTU are installed at the power plants, transmission and distribution substation, distribution feeder equipment, etc. So the electric utility master station, that is located at energy control center, and RTU that will be at power plant, transmission substation, distribution substation, etc. Okay. So let us talk about the master substation. This is part of substation automation. Okay. So master substation, what it is, basically it is a computer system which will be responsible for communicating with the field equipment, and this includes a human machine interface, HMI, in the control room or somewhere else. In a smaller SCADA system, the master station may be composed of one PC. One PC is sufficient. In case of larger SCADA, of course, you require more number of PC. The master station may include multiple redundant servers. Instead of calling a PC, we are calling that as servers. Distributed software applications would be there. Disaster recovery sites will be also included in larger SCADA system. Master station is also called as energy management system when we talk about a large electric utility. So that master station typically has following things, that is one or more data acquisition servers, which is called as DAS, data acquisition servers, or you can say front end processors, FEP, which is going to interface with the field devices via the communication system. Real-time data servers will be there, which is going to contain real-time database, RTDB. Historical servers will be there, which is going to maintain historical database. Application servers will be there, which is going to run various energy management system applications. Like you could think about demand response, one could be demand side management, you could say. It also includes the operator workstations with NHMI. So these basically a master station that would be including our energy management system. Then just what we talk about, what it could consist of. Modern energy management system are your master substation that would be consisting of these things: real-time data server, historical data server, application server, operator workstation second. Then there should be, these all would be linked with the data acquisition server or front end server, and there will be one communication system which is going to link with field devices, that is your distribution transformer, you can think about that. And in modern system, EMS hardware components are connected via one or more local area networks. You know what we mean by the LAN. Many systems have a secure interface to the corporate networks to make EMS data available to the corporate user if it is required. Now if we talk about the modern substation, it could be of different types. In general, let us talk about in general. A master substation can be divided into 5 different categories based on their functionality. Depending upon function, whatever the functions they are going to perform, according to that, it can be divided into 5 broad categories. In certain case, what would happen? The functions of one master station that can cross over the another function of another master station. That is possible. Some function could be overlap. You can think about that. So what are the 5 categories, broad categories of master station? One could be called as SCADA master station. Another can be SCADA master station with automatic generation control. You know what we mean by the AGC. EMS could be the third one. Distribution management system, that could be the DMS. Distribution automation master, that could be 5th category of that. Let us see what are the functions of these master station. Quickly we will complete this. What happened? Okay, it is stuck. Okay, the first one is your SCADA master station. So SCADA master station that will have primary functions, which is going to include the data acquisition, remote control, user interface, areas of responsibility, historical data analysis, report writer, that will include in SCADA master station. Second type of SCADA AGC, which will have the primary functions in addition, these are in addition to SCADA master station. That will be the AGC. The AGC system, when we are calling it as, so its function definitely that will be included in this. That is AGC. Economic dispatch. I hope so you know what we mean by the economic dispatch. Hydro locator, interchange transmission scheduling, network configuration, topology processor, network can be reconfigured basically. These are the big terms, basically network configuration. State estimation, you know about this. Contingency analysis, n-1 contingency, n-2 contingency, all you know. These 3-phase balance of operator power flow, optimal power flow, you know, optimal power flow, dispatcher training simulator. So that is going to include, if your master station is SCADA or AGC system, Okay, so functions are going to change according to that. So whenever you visit any substation, so always keep it in mind these things, that okay, if it is the substation automation is there, so according which functions are basically automation, which functions are part of automation, so you will find out depending upon the name only. The next one is the DMS primary. So its functions are going to include interface to automated mapping, facilitates management, our geographic information system GIS, interface to customer information system, interface to outage management, three-phase unbalanced operator power flow, map series graphics. So basically demand, when demand side is coming, so definitely there will be interface with customer or consumer, you can say. There will be basically management of outage, because you have to provide enhance consumer satisfaction, customer satisfaction is required. Then the DA system, that is going to include your two-way distribution communication, fault identification, fault isolation, server restoration, voltage reduction, load management, power factor control, short-term load forecasting. So these are the functions of master station. All types of master station, they are interfaced with the field device, there is no doubt, because they have to collect the data. Historically, in electric utilities, these devices were RTU, remote terminal units. Historically, they have called it. In recent year, with the proliferation of IEDs, many of these devices are taking over the RTU functionality. So IEDs are basically replacing remote terminal unit. Still it is there, but some of our RTU are replaced with IEDs. We could take in that way. So let us talk about the remote terminal unit. Again, your remote terminal unit, that will be also microprocessor based device. It will be consisting of microprocessor, and the main function is to interface with SCADA and transmit telemetry data to master station. Also, it should have capability to changing the state of connected devices, and this change will be based on control messages, controlling signal. Like if we have given a signal, okay, just switch off the feeder 2 which is connected to the Ratnagiri at Koina plant. So no human intervention involvement will be there. Who is going to do? From remotely you can do that. The RTU provides data to the master station and enables the master station to issue control to the field equipments. Typical RTU have physical hardware inputs to interface with field equipment and one or more communication port. Here what you could see, this is basically one of the remote terminal unit where SCADA system data flow architecture we have shown. Here there is master station, this one is your RTU. So the master station, what it is going to do, supervisory control will be there with RTU. Like you can consider the trip or close signal will be there, or raise or lower, it can be voltage, current, etc. Open or close, again start and stop. These are basically certain control signal. Set point values can be given, okay, these are the set point value, because you know in protections it has significant role. You can change the set point values. Then what RTU is going to give to the master substation, that is the data acquisition status. Alarm, it will also give alarm. Sequence of events, this event occurs first, then second event. Suppose there was earlier line to ground fault, then it converted into double line to ground fault, then might be it converted further to three-phase fault. It could be just taking as an example. So sequence of events, analog data, accumulator data, diagnostic results, that will be given by the RTU. What will be the input to the RTU? That will be the system status, analog, in, pulse accumulator. From RTU there will be also analog output will be as the output. The control, that will be also output. So different RTU process data in different way. But in general, there are several internal software modules that are common among most RTU. Central RTDB that interface with all other software modules, physical input-output application. It is going to acquire data from the RTU hardware component which interface with physical input-output. Data collection application will be there, so acquires data from the devices with data communication capabilities via communication ports. You can think about IDs. Data processing application present data to the master station or HMI. Some RTU also have data translation application which manipulates data before they are presented to the master station, means whatever changes has to be done. If suppose there are certain spikes that can be separated and it can be shown. Our support stand alone functionality at the RTU level. So this is basically RTU architecture you can see at your screen. So this is a simple RTU software architecture. You can see here the master station is there, so there is a communication link. This is your RTU, there is central RTDB, there is data processing application. Then what we talk about the physical input output application, so it is going to communicate with the feed equipment. Here you can see it is going to data collection application that is also going to communicate with ID. The ID is basically there will be the data translation application, several applications will be there in the RTU. So this is one of the architecture you can think of that. Then see, there could be a number of different architecture for substation control system. So one is shown here, that is the server based substation control system architecture. So what will be there? Server based, there will be Ethernet will be there, which is going to connect the network IDs. There could be mini RTU, there can be serial ID which is going to interface with mini RTU, and this is through internet. It is going to connect with the substation server, and which will be consist of serial ID. There will be some communication link, and it will be sent to the master station, EMS, energy management system. Okay, so this is basically a substation automation. Okay, so here we are going to stop. Today we discuss the same thing but in a channelized way, you could say that. Hope things are getting to you, that you need to read. Actually you need to read your own, you need to prepare your notes